Hello, we'll be doing Euclidean geometry, but my plan is to do one theorem or two theorems in each and every session. So I would require you to be fast in responding so that we finish fast because it's useless to give you all the theorems if you don't understand any. So what I want us to do a theorem to prove if it has any converses, we'll give you the converse and then we go to application. If you know how to apply, we move to the two other theorems, right? So with Euclidean geometry, what you'll be doing, it's all about calculating angles. And you're required to know information from the previous grades, like grade 10 and below. So you know things like a straight line and that angles on a straight line 8 up to 180. You know that angles around the point give you 360 degrees. You know that um, you have different types of triangles. Your isosceles triangle, you know that it gives you two opposite angles which are equal. You know about the equilateral triangle, you know about all those things. And so the exterior angles of a triangle, the exterior opposite angle, you know all those things, they are very, very important, right? It doesn't mean that now that we are in grade level, you have to forget all those things because you will need all those things to prove, and you also need theorem of Pythagoras as well. So, if you want me to do a quick introduction on the these things that I'm talking about, just to touch on them a bit, you let me know. But for now, we'll quickly go into grade level stuff. So, what we have to understand is that everything in the Euclidean geometry will be happening in a second, right? So you have to know everything about the second. Firstly, you have to know the center of a second. That one, I won't entertain much. We all know what the center of a second is. So any line that will be passing through the center of a second, that will be moving from this second, we call it the circumference. So if I keep on saying the circumference, I mean this outer second, this second, right? From we have the center, then we have this second. The second, we call it this outer region, we call it the circumference, right? So we have from the center going to the circumference, any line going from the center to the circumference, we call that a radius. And if you have any, meaning this will also be a radius as well, right? So what you have to know is that the radii, if it's more than two, we call it the radii, right? So if these things will always be equal, if from the center to here it's 5 centimeters, also this one will be 5 centimeters. Also, if I take another one from that side going there, it will also be 5 centimeters. They will all be equal, right? So that is what I want you to know about the radius. But if we have line moving from the center all the way to the other side of the circumference, like moving through the center, passing up to the other side. We will call this the whole line, the whole of this line. We will call it what? A diameter. So sometimes they won't give you a diameter, they will give you a diameter, then they ask you to calculate the radius. So a diameter is simply the half of your radius. Right, so that is simple. But if we have a line, let me erase this for now. But if we have a line that is moving the same way as the diameter, but it is passing outside the circle, like that, we call that line about a second. Right, we call it a second because a diameter shouldn't pass to the outside of the second. It should end at the circumference and it should pass exactly at the center. A second shouldn't pass at the center, passes anywhere in the circle, but it goes to the outside, right? So meaning that if you were to have a line that was to move from here and end there, yes, it is meeting one requirement, but it is not a diameter because it's not passing through the center. So the one that is not passing through the circle and it's not passing through the center, we call this one what? A chord, right? So that's a chord. And then the one that is only touching the circle at one point outside, right? So let me try to do it proper. It's touching the circle only at one point, like here. We call that line a what? We call it a tangent. Remember that the tangent is only touching the circle only at one point. The diameter is moving through the center. The second is moving through the second, but not at the same time, it's going outside of the circumference. The chord is touching the circumference, but it's not moving through the center. Trust me, if you know these things, you are sorted. And the space between the chord and the circumference, we call it a segment. Right? So if you know these things, you are sorted, right? You will understand me when I'm talking about all these things that we're going to discuss, right? This is what I want you to know. And then as for the area of the circle and the parameter, we can touch on it a bit also in case they want that, right? But the area of the circle is given by pi r squared, and then whereas the perimeter is given by 2 pi r, right? So that is it. And then when you know these things, you're sorted. So now that you know about all these things, you're sorted. So here's what you will need, right? For each and every theorem that you're going to do, you will need to know the proof of that theorem, right? So when you prove a theorem, always you must have these points. You must have given. By given, you always write given. Given, you write what you're given, right, in the statement or in that diagram, right? So you don't assume things that are not there. Right? You simply, here you're never right or wrong. You state everything that you see in that diagram, right? And then from there, you go to RTP, which is you're required to prove. You state exactly what is it that you're required to prove. And then from there, you go to construct. Sometimes if there is anything to construct, then you say what is it that you have to construct. And then from there, you go to proof, right? And then this is when you'll be doing and then you conclude if you got to required to prove, right? So from there you'll be done, and then that is what you have to do for each and every theory, right? And then you hear me most of the time saying converse. So when I say converse, I simply mean that the opposite. If I check that 1 plus 1 is equal to 2, and then I tell you that 2 is equal to 1 plus 1. This is the converse of this thing. It means that initially you had this, you got that the answer is this. Now you have this, now you can deduce that it's coming from there. That is the inverse. So we are sort of like going backwards, right? Yeah. So now let's start with theorem 1. Let's start with the theorem that says, I'll just say it's theorem number 1. It says you're given a circle, right? And when you're given a circle, you're given the center, and you're given a chord, and it's perpendicular to the, I'll just say this is A and B, right? And they use O for center because most of the time they use O for center, right? So let's say that is the case, and then they ask you to prove that you are required to prove that AM is equal to MB. That is what you are required to prove. So as I said, you always start with your given, right? What are you given? So I'll write it here. Given, what are we given? We're given a circle. We can all see that circle. We're given a circle with points A and B on the circumference. You write circumference in full, and then you can say, okay, here you can say circle with center O, and then you can say comma with points A and B on the circumference, right? And you can see also what you're given is that OM is perpendicular to AB, right? This OM is perpendicular to AB, right? To this. If you don't understand what I'm saying, let me know. And then from there, you're done with your given statement, and then you get your mark. And then if you are required to prove, you write it here, but I already wrote it for you there. So, and then you come to the next step. After this is the first one, the second one, then the third one will be construction, right? So we write construction. What are we constructing? Why are we constructing to start with? We are constructing so that we can arrive to the required to prove, so that we can arrive to this, because if we don't, we are making things difficult for us first. But you don't just construct anything, you construct according to this, what I'm showing you. So you should know this process because they will come right for your exams. So we construct what we join A to B. And when you construct, you do dotted lines, you don't do solid lines, right? We construct like that. So you have to come back and write on the construction but what did you do? You join AO and OB, right? So that is what we did. We joined OA and we joined OB. So by so doing, we're done, right? So we move on to the next step, which is what? Which is proof, right? Which is proof. So let's see what do we proof, right? So on proof, this is what you will write. You write that in triangle OAM, right? Let's see triangle OAM and triangle OBM will go in the same order. OAM, triangle OBM, right? So, or you can say triangle OMA. Yeah, let's make it like that. Other matters, I will show you why other matters, but for now, it wouldn't matter much in grade 11, but you see more in grade 12. So let's say OMA, triangle OMA, and triangle OMB, right? So from there, we have, remember that you have 4 congruencies, right? You have side, 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 you have side, angle, side, you have right hypotenuse side, and then you have angle, angle side. So if you forgot these things, let me know, I will remind you, but I think we did them last year, right? So this is what we start with. You will say OA is equal to OB, right? OA is equal to OB, and always you must give a reason for your statement. What is your reason? If you can see, these both things are coming from the center going to the circumference. And we said anything that is coming from the center going to the circumference is what is the radius. And I told you that the radius will be equal. So the statement will be radii. Right? When you say radii, then you know what you're talking about. You're meaning that you mean that you understand that the radius will be equal. So after that, what follows next is that OM is equal to OM, and the reason is this OM is in both triangles, right? And the reason is common. And then we need one more statement, and then what we have there is that if this is 90 degrees, this is also 90 degrees, right? We can say this is M1 and say this is M2. If M2 is 90 degrees, M1 will also be 90 degrees because the angles on the straight line have to give us 180, right? So I won't write that because of the minimal space, but we'll just say that M1, angle M1 is equal to angle M2 is equal to 90 degrees. They're both equal to 90 degrees. And the reason for that, it's given. It was given to us that this is perpendicular to that at 90 degrees. It was given. So we have a side, we have an angle, but we have this side is in the special side. It is what? A hypotenuse side. If you see, we have a right angle triangle. So we conclude by saying what? By saying that you will write it underneath here, right? We conclude by saying that triangle OMA is congruent. That those 3 lines mean congruent. These ones mean similar. So it's congruent to triangle OMB. And the reason you write it that side, the reason is what is right hypotenuse side. By so doing, you're done. You have proved that if these angles are congruent, when we say that triangles are congruent, we mean that they're exactly the same. So if they're exactly the same, it means that if this are equal and this is equal and this is 90 degrees, this should be equal as well, right? This should be equal to that because they're exactly the same, right? That is what we are saying. I hope that makes sense and I'm not confusing you. So without wasting any more time, let's see the converse. Now we know that when we're given the 90 degrees, that AM will be equal to MB. So what is the converse saying? Now here's what the converse is. The converse of this theorem is saying. The converse is saying that if we are given a circle and we are given the chord and we have but we are not, let's say AM be again with O, but we are not given that it's 90 degrees and they tell us that AM is equal to MB. Automatically this should be 90 degrees. That is what the converse is saying, right? And what is the another converse saying? the converse of a perpendicular bisector. So the converse of a perpendicular bisector says that if you have a circle and you have a chord, and in that chord you have a line that is passing through, but when it passes through, it makes an 90 degrees. This says that this line is passing from the center, and this will be equal to that. So that is the second converse. I don't know if I'm making sense, right? So what I'll try to do is to give you exercises, but let me try and give you one, right? I hope the video won't take long. Okay, but I'm afraid that it will be more than 100 MB, which I can send through WhatsApp. So what I'll do, I will send you this piece. It will be easier and quick for you to finish it fast, and then you come back to me. I give you or we do application, right? Or I will send part 2.